You are listening to The Vocal Technologist. Spoken tech for your ears.
All right, let's just jump straight in. Welcome back to Product Thursdays. So if you're, leading a data team right now, or maybe you're prepping for a big platform migration, or you're just trying to figure out where the budget should go next year, you're going to want to pay close attention. We've gone through just a tremendous amount of material lately, all focused on these huge seismic shifts in data engineering.
Yeah, it's a lot.
It is. We're talking the whole life cycle, from how we even structure data for AI to the brutal tooling consolidation we're seeing,
Right.
and even how a database should fundamentally be designed in 2024. So our mission here is to filter all that and just deliver the core strategic thinking right to you. Cut out weeks of reading.
That's a perfect summary. And what we have here really isn't about, small incremental improvements.
No.
It's a wholesale rethinking of data architecture. Everything is being pulled toward real-time performance and AI operationalization. So we're basically connecting the dots between those really deep technical pieces and what they actually mean for the business.
I love it. Okay, so let's start where the rubber meets the road. The people.
Mm-hmm.
We have to talk about this merging of data engineering and AI. The big looming question is always the same. Is the LLM going to replace the data engineer?
Right. Well, what's clear from sort of the consensus here is that the future isn't replacement. It's radical transformation.
Transformation, okay.
Yeah, data teams are rapidly becoming what the industry is calling LLM native.
LLM data.
So the data engineer's core function is shifting, and pretty dramatically, away from writing routine ELT pipelines.
Extract, load, transform.
Exactly. Or, simple SQL scripts. Because, frankly, the LLMs are getting very, very good at that kind of boilerplate code generation.
So where does the focus go instead?
It's pivoting to more sophisticated platform engineering, to ensuring robust data governance, and this is the most critical part, operationalizing AI safely at scale. Yes, the new data engineer is more of a curator, a strategist. They're designing the system that makes sure models have the right context, and that, crucially, the output is reliable and auditable.
So it's not just about feeding data to a model anymore. We're talking about building the scaffolding around the model.
Exactly.
If the model generates code or an insight, who validates it? Who actually owns that outcome?
The human in the loop. That remains absolutely non-negotiable. For guidance, for ownership.
Right.
Think about it this way. The LLM might accelerate your delivery by, say, 10x, but if you don't validate that output, the error rate is just unacceptable.
So what does that validation look like?
The new role for the DE involves enforcing quality through these governance frameworks, using things like pedantic models to define and validate the structure of the data and the expected output of the AI interaction.
Okay.
This shift, it really turns the data engineer into the chief architect of reliability for the whole AI platform.
It sounds like they're moving from being the executor of a query to the governor of a pipeline.
Yes, that's a great way to put it.
We're structuring the rules and context for the AI, making sure its boundaries are firm. Rather than just writing the code, it can now write itself. That strategic application of tech is, it's why we talk about these dynamics on a program like Vocal Technologist.
Precisely. If the model is the engine, the DE is building the entire dashboard, the steering wheel, and all the safety features.
That need for safety and reliability, that takes us directly to the next huge theme, data quality.
Always a big one.
Always. You can build the fastest, most governed AI system imaginable, but if the data underneath it is junk, the whole thing is meaningless.
It's still the top operational pain point, no matter how mature the company is.
So what's the solution? Is it just more tools?
No. And that's the key. If you look the advice from the leading organizations, it's not about tools, it's a fundamental change in mindset.
Okay.
Data quality has to be treated like software quality.
Right.
We have to move past just reacting to errors after they've already happened.
So being proactive.
Exactly. It means defining what good data even means, domain by domain. It's not one checklist. And then designing layered tests to enforce it.
And automating those checks.
And automating them at the earliest possible stage in the pipeline. It's the concept of shifting quality left.
Right. Catch the error on ingest, not hours later when a critical dashboard is broken.
You got it.
Shifting quality left sounds great on paper, but that's a massive cultural change, isn't it? It means data engineers have to act more like software engineers. Writing unit tests, integration tests.
It is. It did come up. The material notes that this requires uh, mandatory cultural alignment.
Right.
It means making quality testing a non-negotiable part of the definition of done for every single data product. It's hard. It adds friction at the start, but the payoff is a massive reduction in downstream firefighting.
Speaking of firefighting, this is where it gets really practical. For anyone who's ever used an incident management system, the material highlighted a killer of these programs: alert fatigue.
Oh, yeah.
Can you explain the mechanics of this silent killer?
Alert fatigue is just deadly. It defeats the entire purpose of monitoring.
How so?
Well, when your monitoring is based on these, like, overly rigid threshold-based rules, if this number dips below X, send an alert. They just generate a massive number of false positives.
Useless notification.
Completely irrelevant notifications.
Yeah.
So teams get overwhelmed, their inboxes flood, and eventually they just start ignoring all the alerts.
So when a real critical incident happens...
It gets missed, lost in the torrent of noise.
Okay, so how do we fix this? How do we tackle this relentless stream of useless warnings? What did the material recommend?
There's a three-pronged approach.
Yeah.
First, you have to move beyond those rigid thresholds entirely.
Get rid of them.
Implement machine learning-based monitors that dynamically learn the normal patterns of your data. Its seasonality, its expected variance.
So the system knows what normal looks like.
Precisely. And that drastically cuts down on the irrelevant warnings.
Okay, what's prong two?
Second, stop trying to monitor everything. It's a common mistake. Data teams try to put a monitor on every single table.
Boil the ocean.
Right. Strategic focus is key. You dedicate your advanced monitoring to only the critical high-impact tables and the final business-facing data products.
Got it. And the third?
And third, you implement intelligent prioritization and routing. Align alert ownership clearly with the domain teams who are actually responsible for that data.
So the right person gets the alert.
Yes. And critically, you prioritize those alerts based on their downstream impact. An alert that threatens some internal dashboard used once a week gets a lower priority than one that affects high-stakes financial reporting for the CEO.
That tiered approach makes perfect sense. You fight the fatigue by making every alert that does come through feel truly valuable.
Exactly.
Okay, let's pivot sharply from operations to the marketplace itself. The material points to a major dynamic that really defined the last year, a brutal wave of acquisitions and consolidations. It's fundamentally shaking up the whole idea of the modern data stack.
This is truly the signal that the stack wars are. They're intensifying. It's the end of the assumption of default modularity.
So what are some of these big strategic mergers we saw?
Well, think about Fivetran merging with BBT.
Huge.
Right. That instantly creates a much tighter, more unified link between the ingestion layer getting data in and the transformation and modeling layer.
And Confluent.
Confluent joining forces with IBM, integrating real-time stream processing into a massive, entrenched enterprise sales platform.
But the biggest signal?
The biggest strategic signal was this. Both Snowflake and Databricks, the two giants, both of them bought Postgres companies.
Why? What does that signal?
It signals that they realize they need to own the entire pipeline. That includes the high-speed transactional use cases that traditional data warehouses just weren't built for.
So what does this tell us about the landscape? Why are these huge platform leaders spending billions to buy what seem like small components?
It's all about control, integration, and pricing simplicity. The market is consolidating around these core integrated platforms.
So independence is no longer the default?
Not at all. It's now a strategic choice you have to actively fight for. The vendors are racing to control more of the workflow.
And they claim flexibility,
But by deeply integrating ingestion, transformation, and storage, they create this incredible commercial and technical stickiness. It simplifies billing for you, sure, but it also makes it incredibly difficult for a competitor to wedge themselves into your workflow.
Which means for any data leader listening, there's massive pressure to choose very deliberately. You can't just assume you can easily swap components out later.
Not anymore. The modern modular stack of today is almost certainly going to be tighter and less flexible tomorrow. You have to evaluate that long-term trade-off.
The speed of an integrated platform versus the freedom of a truly open multi-vendor architecture.
Exactly. You have to decide now what level of vendor lock-in you're willing to accept for that guaranteed integration and simplified maintenance.
All right, let's move into some specific architectural challenges. If the big goal is real-time AI, then performance and latency are everything. What was the crucial detail in the material about Dropbox Dash's feature store?
Oh, that was a fantastic case study in optimizing for speed.
Yeah.
So Dropbox Dash has an AI system that needs to handle tens of thousands of parallel feature lookups per query.
Wow.
And they set a very strict goal. Sub-100 millisecond latency.
Auspicious. What was the bottleneck?
The immediate bottleneck they hit was Python, specifically the Global Interpreter Lock, the GIL, which cripples true concurrency.
So what was the fix?
A classic performance engineering move. They rewrote the core high-throughput serving paths in Go.
And the result?
A dramatic performance increase. They pushed their P95 latency, so 95% of queries execute in this time down to a blazing fast 25 to 35 milliseconds.
That's incredible. It just shows that convenience has to take a back seat when that kind of AI performance is the goal. But even massive scale and high performance doesn't guarantee stability. We have to talk about that massive Snowflake outage.
Right. The Snowflake incident is a crucial and probably very expensive reminder about control plane fragility.
Can you define control plane for us?
Sure. The control plane is the shared global metadata layer, the coordination logic that dictates how all the regions and services communicate. It's separate from the data plane, which is where your actual data and compute live.
So what broke?
The problem was a breaking schema change in that shared global control plane. It caused a 13-hour outage across 10 regions simultaneously.
Ouch. So the big takeaway?
It's a bit unsettling. It's that deploying a multi-region setup doesn't inherently protect you if that shared logic layer, the control plane, is the source of the failure.
I can only imagine the war room during those 13 hours. Okay, staying on architecture. The material spent a lot of time on how modern hardware, like fast SSDs, is forcing a rethink of database design. Why are Postgres and MySQL considered legacy designs now?
Because they were built for a different era, an era of slow mechanical hard drives.
Right, spinning disks.
Their whole architecture relies on heavy logging, large data pages, complex single-node recovery, all to guarantee durability when the hardware was unreliable. But today, with fast SSDs and cloud replication, those choices are actually performance liabilities.
So a modern cloud-native database is different how?
It's optimized for the new silicon. It pushes durability and availability out to distributed systems. It's optimized for small, fast data transfers. And it can largely drop those heavy legacy recovery mechanisms.
It's built for flash storage and high-speed networks, not the spinning disk.
You got it.
Okay, let's zoom in on something near and dear to every executive's heart. Business intelligence. BI. The material made a really powerful argument here. Basically, why your next BI renewal should be your last. Unpack that for us.
So the consensus is that legacy BI tools are just. They're getting squeezed from the top and the bottom.
Oh, so.
On one hand, you have AI-native analytics that can answer questions directly, dynamically. On the other, the data platforms themselves are moving up the stack to own the metric layer.
And the legacy tools are stuck in the middle.
Exactly. They rely on static dashboards that require a human to manually hunt for insights. They were built for a world where humans were the only consumer of metrics.
That world is changing.
It's changing fast. The incumbents are trying to respond with, price hikes and some weak AI bolt-ons, but the core architecture is obsolete.
So if we're not reinvesting in traditional BI, where does that strategic investment go?
The value is shifting decisively. It's moving away from human-facing dashboards and toward governed, machine-readable metrics and semantic layers.
And that's the key takeaway for anyone listening.
It is. Data leaders have to invest in flexible metric foundations that can power anything. An LLM agent, a custom app embedded in a workflow, a self-service tool.
So the goal is to deliver insights directly into the workflow.
Yes, where decisions are actually made. Instead of forcing users to log into some centralized static dashboard to go find them, the future consumer of your metrics is increasingly non-human, and the semantic layer has to cater to that machine-driven demand.
That covers a huge amount of ground. From Go versus Python all the way up to stack consolidation. Let's bring it home. What are the 3 definitive strategic takeaways from all this?
Okay, first, the data engineer has to internalize their new role. They are an LLM native platform strategist. The focus is governance, validation, and safe operationalization of AI.
Shifting from plumbing to policy.
That's a perfect summary. Second, data quality cannot be an afterthought. It requires disciplined, software-like processes shifting quality left, and you have to use intelligent prioritization and ML monitoring to fight alert fatigue.
And the third.
And finally, the entire data stack is consolidating rapidly. This is driven by competitive pressure. It means deliberate long-term platform choices are essential today. Assuming you'll have modularity in the future is just too high of a risk.
And if you're wondering where this is all headed, this convergence of AI native architecture and consolidation, the final provocative thought was centered on a concept called DA2A.
That's the prediction. The future data platform is agentic, distributed, and collaborative.
Okay, what does that mean?
It means instead of centralized platforms that rely on human engineers for every query, you'll have specialized AI agents that autonomously manage their own domain-specific data sets.
And they talk to each other.
They collaborate, using an agent-to-agent protocol to efficiently and accurately answer complex business questions across silos. It's a completely new paradigm of automated data cooperation.
Agent-to-agent protocols governing autonomous data systems. That sounds like the operating system of the future business. And it completely changes the role of the data team all over again.
It does.
What an incredible dissection of where things are moving. If you want to explore agentic platforms or the huge implications of stack consolidation, you certainly have a clear map now. Thanks for joining us.
Spoken Tech for your ears.